Okay, so in this lesson we are using properties of exponents. Pretty simple. Just one objective here, simplifying numeric and algebraic expressions using properties of exponents. Okay, something that possibly you remember from Algebra 1, like whenever you multiply, what do you do with those exponents whenever you divide, things like that. Okay, so again, just one objective, being able to simplify expressions that have powers, properties of exponents, either with numbers or with variables. In this image here, this is taken from an advertisement for, if you can look down at the bottom of this picture, genuine Volkswagen accessories. And you can see the little Volkswagen symbol is used as an exponent on the larger one for some reason. I'm not going to discuss exactly why, because maybe you're going to see this image again soon. Anyway, so here's a warm-up question here. Consider the algebraic expression 3, and then you have parentheses, 2x plus y. So we know usually we think of that 3 as being distributed through here, right? The 3 times the 2, I'll just go ahead and write it. 3 times the 2 to get 6x, and 3 times the y to get plus 3y, right? That's usually how we think of it, but this also means that you have 3 copies of the quantity or the expression 2x plus y, right? So here's an illustration of this. So here I've got 2x wing fighters plus 1y wing fighter, and I have basically 3 copies of this. So each one of these represents graphically or visually the expression 2x plus y, okay? And what 3 times that means is that you are just repeatedly adding those things together. It means the first one plus the second one plus the third one, right? We know this. This is some basic algebra. So for example, I should get the same answer if I just add these things up. The same answer that I got from distributing 2x plus the other 2x plus the other 2x, that gives me 6x. Y plus y gives me the 3y. Okay, no problem. Okay, so now let's modify this a bit and now consider the algebraic expression 2x plus y raised to the 3rd power, so that 3 is an exponent. So what could be done to that previous illustration where each one of these represents 2x plus y to represent that power, that exponential quantity? And the answer is that instead of adding these things, we're multiplying these things together. That this exponents means repeated multiplication. All right, so that's the key thing there, is that exponents simply mean repeated multiplication. Okay, and another thing that I'm going to point out to you is something that most people make a mistake on. It's understandable. The 2x plus y, you're so used to doing the distributive property that you want to give the 3rd power to both of these things and say, hey, this is equal to 2x cubed plus y cubed. But it is totally not equal to that. It means this quantity times that quantity, and you'd have to FOIL it out. Okay, you'd have lots and lots of terms. Okay, so exponents. Look at that expression here. 2 to the 3rd is equal to 2 times 2 times 2, because what we just said, that exponents simply mean repeated multiplication. The 2, the big 2 there, is called the base, and the 3 there is the exponent, right? Okay, so exponents, again, just mean repeated multiplication. Okay, so on this first exercise, let's just expand out or simplify these expressions. This will help us in the little investigation that you're going to do to rediscover the properties of exponents. So on this first one, write 2 to the 4th in expanded form. So 2 to the 4th means 2 times 2 times 2 times 2, right? It is 4 copies of 2 that we all multiply together, okay? Likewise, the one with the variable here, x to the 3rd power, simply means x times x times x. It's 3 factors of x. Okay, so on the 3rd one here, this is a power raised to a power. 2 to the 3rd squared, which means 2 to the 3rd times 2 to the 3rd. Okay, and then you could expand this out a little bit more and go that this is 2 times 2 times 2 That's the first one. There are 3 factors of 2. And then the other one is exactly the same thing, 2 times 2 times 2. And I count these things up. I have 1, 2, 3, 4, 5, 6. I have 6 factors of 2. Right? Okay. Number 4, last one on this list. 2 x squared divided by x. This means 2 times x on the top. And on the bottom, I'm dividing this by x. The x that's on the bottom can divide into one of the x's on the top. X divided by x, as long as that x is not 0, should be 1. It's like 5 divided by 5, 6 divided by 6, or whatever, which simplifies to 2x. Okay, so what we're going to do is put this stuff together and kind of try to come up with some general rules for the properties of exponents. We're rediscovering what is called the multiplication and division properties and power properties with exponents. And here this one was not one that was created in an advertisement. I just made that one for you, similar to the opening graphic there, the exponent being Apple on the AT&T logo. Okay, so the first one, multiplication. Step 1, I want you to take each one of these expressions, there's 4 sets there, and each product, and write it in expanded form, okay, with expand it out and then try to compress it down to just a single base if you can, and then compare your answers and try to come up with step 3, some sort of generalization. Okay, so I want you to genuinely pause the video and do these yourself. Okay, alright, so did you remember what the property was? Did you see the shortcut here? So here are all the answers that I came up with. So you write down 4 copies of the 3, multiply times 2 factors of the 3, and you have a total of 1, 2, 3, 4, 5, 6. I have 3 to the 6th, and I originally had 3 to the 4th times 3 squared. What could you do with the original problem to arrive at that answer? Well, 4 plus 2 equals 6. You could just add up the exponents. Okay, same thing on the next one. I have 3 factors of 10 multiplied times 6 factors of 10, and if I count up all of my factors of 10, I get 9 of them. What could we have done with the original problem to get that? Well, if I add up my exponents 3 plus 6, I could have gotten it. Same thing with the next one. 3 factors of x times 5 factors of x. Add them all up, I get 8 factors. So x to the 8th, I could have just added up the exponents. Okay, so again, I see the same thing playing out with the a to the second power times a to the 4th power. 2 plus 4 is 6. That's exactly what my exponent turns out to be. So the shortcut here, as long as you have like bases, b to the m times b to the n, you just add up your exponents keeping the same base. That's equal to b to the m plus n power. Okay, keep the same base, add up the exponents. Easy. Piece of cake. Alright. The second one is the power rule. So here you have powers raised to powers. Expand those things out, try to simplify them, compare it to the original problem, and then try to fill in these 2 blanks here. Okay? So go ahead and pause your video for a sec. You work them out yourself, and then come back and let's check. Alright, so here are the answers that I came up with. In the first one, 4 to the 5th power squared means 4 to the 5th times 4 to the 5th. I have 2 factors of that. And each one of those in the parentheses is 4 times 4 times 4 times 4. It's 5 factors of each one of those. If you add up all those factors, it's 4 to the 10th. Look at the original problem. What could I have done in order to get the same answer? 5 times 2 is 10. I could have just multiplied my powers, right? Same thing with the second one. X to the 3rd raised to the 4th power. That means there are 4 factors of x to the 3rd. 1, 2, 3, 4. Each one of those, well, I just applied the multiplication rule here for the first 2. Add up the exponents, get a 6. Add up the exponents, get a 6. If I do that again, add up the exponents, 6 plus 6 is 12. That was the way I chose to do it. I could have looked at the original problem and saw that I could have just multiplied the 3 times the 4 and got a power of 12, which is what the answer was. Okay, so you had to have kind of grasped what was going on in order to do the third one. So 5 to the m power, all of this raised to the n power. This means that you have n factors of 5 to the m. So I did 1, 2, dot, 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 times 5 to the m. let's just assume that there are n of them, which means that if I use the multiplication rule, that I'm just adding up n copies of that m. That means that it is 5 to the m times n. I just multiplied those exponents together. And it doesn't matter if there are multiple things in here. X times y raised to the third means that I have 3 factors of x times y. If I add up all the exponents on the x's, 1 plus 1 plus 1, you get to the third power. Y plus y, 1 plus 1 plus 1 for the y's, you get y to the third power. This whole thing could have been gotten as if you were to have given this 3 to both things inside here. It's like a distributive property. Okay? So, here are your 2 generalized answers here. B to the m, all of this raised to the n, you just multiply your 2 exponents together, b to the m times n. Okay, if you have more than one thing inside the parentheses, that is being multiplied. A times b raised to the n power, you're going to give that n exponent to both of them, almost like a distributive property, but I kind of don't want to call it the distributive property because that's why some people make a mistake with this. So it's a to the n times b to the n. Okay, there's one more property here, is the division property. So check these out. So expand these things out, cancel factors if you have some on the top and the bottom. Write it in simplest form, and then compare it to the original problem. Try to generalize your observations by filling in that blank right there. Okay. Again, pause the video. Okay. So here we go. On each of these, the first one, it means I have 9 factors of 5 divided by 6 factors of 5. And whenever I divide these things, I just cancel out all the ones they have in common. When I cancel them out, 5 divided by 5 is technically 1, right? That's what's happened when I cancel these things out. When I look, I have 3 factors of 5 left over. That's 5 to the third. Look at the original problem. What I could have done is looked at exponents and just said 9 minus 6 equals 3. I could have subtracted them, right? So the division seems like it's a subtraction of exponents. So I have a couple of different things happening on the middle one. I have 3 factors of 3 times 3 factors of 5 divided by 3 times 5. Cancel out all the ones that they have in common, and I'm left with 3 squared times 5. 3 squared, well, this is as if there's an exponent of 1 on that 3, and 3 minus 1 gives me the exponent of 2. And the same thing on the 5s, 3 minus 5 gives me a 1. This is as if I have exponent of 1. Okay, so the same thing plays out on the last exercise. If we were to just subtract these exponents, where did my pen? There we go. Subtract 4 minus 2, I get 2. 6 minus 3, I get 3. So here, whenever you're dividing with like bases, you keep the base the same and you just subtract the exponents. So b to the m divided by b to the n means b to the m minus n. It's always, write this down, top exponent minus bottom exponent, okay? Always top minus bottom. So here, this one summarizes those 3 things that we just rediscovered, the properties of exponents. The first one's called the multiplication property of exponents, that if you have like bases, b to the m times b to the n, you keep the base the same, and then you just add up the 2 exponents. Okay? The power property of exponents, if I am raising a power to a power, I just multiply the 2 exponents. So b to the m raised to the n power, b to the n, m times n power. Okay. If I have multiple things inside the parentheses that are being multiplied together, both of those things get that exponent. So AB quantity to the n power means a to the n times b to the n. And then finally, the division property of exponents. Whenever you divide with like bases, you keep the base the same and then subtract the exponent. So b to the m divided by b to the n means b to the m minus n. Okay? Alright, so in the next video we will practice using some of those properties of exponents in some exercises.